So advantage of using this fluid is that the mass density of this fluid can be obtained easily, and they do not stuck, means attach to that particular fluid, particular this one also, particular material also. So this is also one of the mean. That's why liquid we people are using. Mercury is not attached to the glass tube, and water is also not attached to the glass tube. If a sticky material is used at that time, there will be a problem of the variation in the height. Second one is the well type. So if you observe the well type, the similar working is there. The similar working is there, but the variation in the change, variation in the height is very small compared to that of YouTube nano. So here we people are having a well type or reservoir type manometer also. So don't get confused that if the question is that specify, write the short note on reservoir type of manometer or well type manometer. Though we have studied well type manometer, but then and then also this is also called as a reservoir type of a manometer also. Okay, and the working principle is also similar to that of YouTube manometer. Only the difference is that here in this particular aspect also, here we people are applying a higher pressure. Here at this end we people are having the lower pressure. Okay, so we are having P1 minus P2 similar to that of YouTube manometer, which has been given as rho GH. What type of liquid we are using, whether mercury or whether water, depending on that we people are going to get G, and my rho height can be determined based upon the applied pressure P1. So either instead of P1 minus P2, you can represent it one as a delta P, because delta P is nothing but P1 minus P2. Okay, so this is also can be used for the unknown pressure measurement using well type. Only the difference is that the variation in the height which we are getting using the well type of manometer is less compared to YouTube manometer, because the area under consideration is the minimum in YouTube manometer compared to that of well type manometer. So here this one is commonly used in the industrial application, uh, and widely there is a widely percolation of such a type of devices. So widely used because inconvenience, the reading of only a single leg is to be measured. That is, we are not measuring the variation of the well, but we are measuring the U tube, smaller diameter tube we are using for the measurement of the height. So it consists of a very large diameter of a vessel, similar to that of a well, which has been connected to the side of a very small size tube. And the variation which we are getting, measured variation which we people are trying to measure, is of the small size diameter. So thus a zero level moves very little when pressure is applied. So liquid, I have already specified to you people. Now the another one is inclined type of manometer. So in inclined type of manometer is also similar one. Here we people are having a large vessel. Here we people are having a inclined tube which is connected to the large vessel. And at this particular moment, if you try to observe what variation we people are getting, so here we are applying the P1, and here we people are applying P2. Whatever may be the variation that we people are getting for the unknown, one may be for atmospheric pressure, one may be for unknown pressure, or both may be the unknown pressure, but whichever one is the greater one, suppose I have applied a pressure of P2 over here which is greater, there will be variation, there will be variation, or this one is greater one, it will move in the downward direction. This particular flow will try to move in the upward direction. So what we people will consider for understanding purpose, suppose I have considered the pressure P1 which is applied is unknown pressure, and P1 is greater than P2. P1 is greater than P2. What is going to happen? But after applying this particular pressure, the height of this vessel will increase. So here we people are having the change in the height of the leg, having a angle theta. Inclination is nothing but this is the angle theta. It has been inclined. So large change in the smaller tube will occur. So as per as the definition has been considered for this one, we are having delta P. Why I am specifying, though P is equal to your rho GH, but our P is now replaced by two pressure, that may be P1 minus P2. And depending upon whether your P1 is greater or P2 is greater, depending on that, we people are trying to determine this value. So for inclination type, what we people are trying to determine is that what output is supposed to be generated and how we people are measuring that particular output. So concept is very simple. P is equal to rho G H as per as the definition which we have seen. However, P is replaced as delta P, but delta P is equal to P1 minus P2, that we have already seen. And if I replace this delta P, so I will represent delta P is nothing but P1 minus P2 rho G H. Now what is H? H is represented in this case as a capital H, but H is equal to L sine theta. If I replace that H by L sine theta, I am going to get my P is equal to rho G. H is nothing but L sine theta. L sine theta. So my P1 minus P2 is equal to rho G L sine theta. Rho G L sine theta. So this is the expression. We people are having angle theta. We are having angle theta over here. This is the angle theta. We are well aware while designing that particular instrument. Then we are having rho. Then we are having G. One of the parameter is known. Suppose atmospheric parameter is known. So we can easily determine the value of P1. Yes, we can easily determine the value of P1. Likewise, here we can determine the value of unknown pressure by using U-tube manometer, then well type manometer or reserve type manometer or inclined type of manometer. So inclined type of manometer that also provides a single leg and single scale reading, which has been expanded along the single tube, as we have seen in the previous case. That will be linearly increasing per unit vertical height than a equivalent vertical scale of the well type manometer. So it is also having the greater reliability, and that particular reliability is plus or minus 0.01 inch than or compared to that of your U-tube manometer. So the angle of the inclination alpha or theta, in the previous case we have considered. So you just replace this alpha by theta. So angle theta, inclination theta is generally about 10 degree from the horizontal. So you just replace that value as the terminology. So here if I want to represent the expression, P1 minus P2 is equal to rho G. H is nothing but L sine theta. So I am having the value here instead of angle theta. So you just replace that theta by 10 degree. You are going to get L can be determined based upon the observation of that inclined one. Starting from this part to this part, this is nothing but your L. So you can easily determine what is the L. So replace that value L, you are having theta 10 degree, rho and G is known, any one of the pressure is known to you people. Replace that value, you are going to get the unknown pressure P1 or unknown pressure P2, whatever, whichever may be the unknown one. You can easily identify and you can easily determine that unknown pressure. Now, one of the pressure is known to you people. So likewise,